Okay, so let's just jump right in. We're doing a deep dive today on a topic that it really affects every single piece of technology the military uses. And I mean everything. We're talking from the smallest firing pin on a rifle all the way up to, I don't know, the networked command system in the largest armored vehicle. And that topic is standardization. It's thorny, it's complex, and it's absolutely critical.
It is. And this isn't just about, making sure the plugs fit. What we're really digging into here is how the military's current approach to standardization. Well, it's a classic case of the solution becoming the problem. On the surface, you need it for allies to work together. It's essential. But the way it's being done is, and the sources are very clear on this, it's ironically creating these profound flaws. It's creating technological lag and a very, very dangerous logistical fragility across the entire Western industrial base.
That's the core tension, isn't it? That's what we have to wrestle with. You've got the Department of Defense and all its allied counterparts, and they desperately need everything to be interoperable. That's a given.
Yeah.
But the sources we're drawing from today, primarily this one, really compelling white paper on military acquisition. It makes this forceful argument that the traditional method, dictating unique standards from the top down, it's just structurally failing in the digital age.
It is. The authors argue for a radical shift, a really fundamental one. They're saying we need to abandon custom military specifications.
Mil STDs. Little mil STDs. Yeah.
Exactly, the ones everyone in the industry groans about. And instead, they say we have to fully embrace the global, the consensus-driven industry standards.
So things like ISO, IEEE, that kind of thing.
That's it, the stuff the rest of the world already runs on.
So that's the mission for this deep dive. We're going to explore that revolutionary shift. We are moving from what the paper calls the mechanical mindset, which is all about physical specifications, like the precise length of a firing pin or, I don't know, a proprietary recipe for gunpowder. And we're moving towards what they call the digital mindset, which is all about scalable software ecosystems, network data flows, complex hardware integration, where milliseconds matter a lot more than millimeters.
And we really need to understand the mechanism here, the how. How can profit-driven commercial cooperation, which, naturally seeks the widest possible market, how can that become the key? The essential and, frankly, the overlooked key to enhancing military lethality and, maybe more importantly, global industrial resilience.
And I think the central thesis, the thread we're going to pull through this whole conversation, is that lethal military capability. It's best achieved when the military defines the outcome it needs, the function the tool must perform.
The what, not the how.
Exactly. The what, not the how. Instead of dictating the detailed specification of how that tool has to be built. And that demands a complete, and let's be honest, a probably scary reversal of the traditional acquisition culture. So let's start with the diagnosis. The sources lay out this hard truth. Why are the current military acquisition strategies, specifically how they approach standards, why are they structurally flawed? Especially now, now that warfare is just so dominated by digital systems, by ones and zeros.
Well, the flaw is it's deeply rooted in history. It makes sense if you look back. For decades, when alliances like NATO were first formed, interoperability was all about mechanical standards. And that was the right focus. Think about the 7.62 millimeter ammunition standard for NATO.
Right, a classic example.
Or the size of a fuel nozzle on a truck, or even just the basic connection points for tow hitches. These were simple physical agreements. And they were absolutely necessary for nation-to-nation cooperation, for logistics in the field. If a U.S. machine gun ran out of ammo, it could use British or German rounds. That was, and it still is, crucial.
But the sources seem to draw a very, very sharp line here.
Yeah.
They point out that this mechanical mindset, it just fails. Catastrophically, I think is the word they use. It fails when you try to apply it to the digital layer. You just can't negotiate a software protocol.
No.
Or a secure data transmission standard in the same way you agree on the size of a rifle bore.
That is the critical insight. The pace of change is it's fundamentally different. Think about it. When you mandate a mechanical standard like a bolt thread size, that standard can last for 50 years, maybe longer.
Sure.
But if you mandate a custom military standard for a digital component, let's say a specific communications chip or a thermal imaging sensor spec, that standard is obsolete in 18 months.
Or less.
Maybe 6 months, yeah. Because commercial R&D is just moving so much faster. It's a tidal wave.
And this brings us right to what the paper calls the bureaucratic lag. Because these standards, even military ones, they don't just appear out of thin air. They have to be negotiated.
Exactly. They are negotiated. And often they're negotiated by diplomats, by politicians, and by high-ranking but non-technical officers. And these are brilliant people in their own fields, but they just inherently lack that granular technical expertise. So the whole standard setting process becomes a political exercise, not an engineering one.
Can you give us an example
Hmm?
of the kind of technical detail that gets lost when the process is driven by political timelines and not, engineering reality?
Oh, absolutely. Think about something complex like modern electro-optics. The technical experts, the engineers, they understand the precise requirements for optics brightness in different environments, or the necessary thermal dissipation rates for a ruggedized combat computer that has to operate in a, 130-degree Fahrenheit desert.
Things a diplomat would never even think to ask about.
Never. Or, to use an older example, the complex thermodynamics of bore pressure that are required for a new high-velocity tank round. These are incredibly nuanced, highly technical specifications. So if the standard is set by some international committee that's just looking for the lowest common denominator, the easiest thing to get everyone to agree on politically,
Then the tech is mediocre from day one.
it's mediocre, it's underperforming, or it's simply obsolete the moment the ink is dry on the agreement.
So you're not getting a standard based on the cutting edge. You're getting a standard based on the political timeline needed to get consensus,
Yeah.
which means the standard is fundamentally flawed right from the start. And it's set by people who don't have to face the enemy using the gear.
Exactly. And that leads directly to this dead end of custom specifications, the creation of these unique MIL STDs. When the Department of Defense decides it needs a specific piece of technology, and instead of just choosing a commercially available, globally standardized product, it goes off and creates a unique proprietary military specification for it. It creates this profound self-inflicted technological quarantine.
Self-inflicted technological quarantine. That is a powerful phrase. What are the real operational consequences of that isolation? I mean, beyond just the soldier being frustrated with old equipment.
Well, the sources detail three really critical interwoven consequences that, they argue, fundamentally undermine national security. First, and most obviously, costs dramatically increase.
Because you lose economies of scale.
You completely lose the massive cost advantage of commercial scale. Instead of buying millions of standardized components off a global assembly line, you are now buying a few thousand bespoke, custom-made items from a single supplier.
Okay, that's number one. What's the second consequence?
Innovation slows to a crawl. I mean, a dead crawl. The military is now completely cut off from the rapid, multi-billion-dollar R&D cycles of the global commercial sector. Companies like Samsung, Apple, Google, Cisco, they're spending more on R&D for processors and network solutions in a single quarter than the Pentagon might spend in 5 years on some proprietary communications program. When you mandate a unique spec, you instantly cut yourself off from that entire tidal wave of global innovation.
And the third danger.
Profound hardware fragmentation. This one is insidious because every program manager insists on their own unique standard, their own special chip, their own communications protocol. You end up with dozens, maybe hundreds of mutually incompatible systems across the force. So instead of one standardized operating system or network architecture, you get this fragmented, chaotic technological landscape.
Which makes integration in the field a nightmare.
A nightmare. Incredibly difficult, incredibly costly, and deeply unreliable when it matters most.
Let me see if I can use an analogy here. By insisting on a unique military standard for something that could be met by a simple, say, ISO standard, the military is essentially forcing itself to use boutique technology.
That's a great way to put it.
It's like demanding a military-only version of USB-C or Wi-Fi 6 that only 2 specialized defense contractors can build. So you pay this massive premium for a system that's slower, less functional, and gets replaced by the commercial market every 6 months anyway.
That is the perfect explanation of the cost-benefit disaster. It's a catastrophe. They are paying exponentially more for a solution that provides them with technological obsolescence, with fragmentation, and with unique logistical burdens that the commercial sector has already solved. Solved it through ruthless competition and global standardization. The goal should be so simple. Leverage the global standards that work for the military, not create military standards that only work for one proprietary contractor.
It really does seem like the entire structure encourages this kind of technological parochialism.
It does. And the problem is compounded because the DoD, often with the best of intentions, trying to stimulate innovation, it actually stifles it. It stifles it by dictating the solution instead of defining the problem. They're so busy trying to design the car that they completely miss the global race to build the fastest engine. And to move this whole analysis from, this abstract idea of bureaucratic flaws to a concrete operational reality, the sources offer a truly compelling and frankly exasperating real-world example of exactly how this government-led standardization breaks down in practice. We need to talk about the NATO mobile bridging gap.
This anecdote, yeah, when I was reading it in the source material, it reads like a script for a satire on bureaucracy. It's almost unbelievable. So tell us about the specific nature of this problem with the mobile bridging systems.
It is astonishingly, maddeningly simple. It involves the U.S. multi-role bridge companies, the MRBCs, and key allied bridging systems, specifically from major European allies. For at least 5 years, a known incompatibility has existed.
And what is it?
Physically, the bridge sections don't connect, the pins don't line up. So if you need to span a wide river and you try to use a U.S. bridge unit and, say, a German bridge unit, they cannot link up seamlessly to form one continuous crossing.
That seems like the single most basic requirement for a multinational alliance's engineering core. It's literally job number one. And the sources point out that the fix is just laughably trivial. It's a specialized, inexpensive adapter. A simple piece of connecting hardware.
A trivial, inexpensive adapter, yes. We are probably talking about maybe $5,000 per adapter unit.
Yeah.
Tops. But here is the structural breakdown. Here's where the system fails. Because this adapter was not part of the original rigid multi-thousand-page government specification that dictated the bridge design, it has not been procured.
Wait, so they can't buy it?
The official acquisition mechanism, the one dictated by the MIL STD, cannot procure this trivial piece of metal. It's an easy, obvious fix that is functionally impossible because of paperwork inertia and the sanctity of the original spec sheet.
That has to lead to the kind of immense and completely unnecessary waste of intellectual capital the paper mentions.
Oh, absolutely. Think about the resources just poured down the drain. Instead of spending that trivial sum to just buy the adapter, military logisticians and strategists have wasted immense intellectual energy and millions of dollars rewriting doctrine and tactics, techniques, and procedures.
Or TTPs.
The TTPs, exactly, just to work around the fact that their bridges don't physically connect. So now you have soldiers who are already under immense pressure being trained to conduct these needlessly complex, multi-day, multi-phase operations just to move a division across a river, all because the system is incapable of buying a simple piece of metal that costs less than a single combat helmet.
I can just picture the poor platoon leader reading that newly updated manual, knowing full well that a $5,000 piece of equipment could just negate 40 pages of these complex workarounds. It has to be demoralizing. And it fundamentally undermines their ability to execute operations with any kind of speed.
And the root cause analysis, according to the sources, is crystal clear. The Department of Defense is solely blamed for dictating a unique, incompatible specification in the first place, rather than simply defining the required capability.
Okay, let's break that down. How would defining the capability have prevented this mess?
Well, had the initial demand been placed on industry in a capability-based way, for instance, if the request was, provide a combat bridge that interoperates with standard European heavy construction load limits and coupling mechanisms,
The problem would have solved itself.
the manufacturers would have standardized the coupling interface decades ago, instantly.
Why?
Because the market incentive is immediately aligned with interoperability. They want to maximize their sales. They want to sell to the US and France and Germany and every other NATO member. Profit and market share would have driven that interoperability on day one, completely removing the need for governmental intervention or bureaucratic negotiation or these incredibly costly redesigns down the line.
So the rigidity of the spec creates this immediate operational absurdity. But that rigidity also fosters a second and maybe more insidious problem: the creation of these dangerous self-reinforcing monopolies. This is the monopoly trap and logistical fragility.
The connection is direct and it is poisonous. By enforcing these unique military-only specification specs that purposefully deviate from any commercial norm, the DoD inadvertently creates and structurally reinforces monopolies. This is what the source calls the single ecosystem failure. If the specifications are so unique and so proprietary, then only one prime contractor, or maybe two if you're lucky, can possibly meet them. And that just hands the contractor an exclusive government-guaranteed market share for decades.
And what's the real danger of that single source risk? Especially when you're planning for, a high-intensity global conflict.
The danger is profound, and it relates entirely to scale. These defense-only companies, the ones beholden only to these unique military specs, they lack the commercial volume to maintain massive, scalable production lines. They're running a boutique operation. It's tailored only to military orders, and they're often only producing a few hundred units of a given item per year.
So if they are suddenly asked to quadruple production, say in the first 90 days of a major conflict, they just can't do it.
Yeah.
Their whole supply chain, their tooling, it's all designed for scarcity and high cost, not for mass production.
Precisely. They cannot surge production in wartime. It's not in their DNA. In peacetime, they function adequately, generating predictable profits for their shareholders. But in a contingency, a world war, when every piece of equipment is being consumed at unprecedented rates, these monopolies are logistically incapable of scaling up. They don't have a commercial production line which operates on global standardized components that they can just repurpose for rapid mass military output.
So they're restricted by the limits of one proprietary factory, built around one unique Millis STD. Meanwhile, an adversary might be running a standardized commercial supply chain at massive scale. That's an incredible self-imposed strategic vulnerability.
And it feeds the system. It creates this loop, what the sources aptly name the revolving door of stagnation. You have military program managers, and they're often just focused on reaching their next permanent change of station, their PCS, or getting to retirement, so they are completely disincentivized from rocking the boat. They know that adopting new, innovative commercial standards introduces complexity and career risk to their program.
So the safest career path is just to maintain the status quo, even if the status quo is technologically inferior and more expensive.
Exactly. The system rewards managers who prioritize contract stability over rapid capability delivery. And, as the paper details, this cycle gets cemented when retiring senior officers are then hired by the very monopolies they just finished supervising.
It's a revolving door.
They move from managing the contract on the government side to managing the contract on the industry side. And that perpetuates a culture where maintaining the current, expensive, unique contract structure matters far more than leveraging the global market for a superior, rapidly scalable capability. The system rewards maintenance over innovation and stagnation over speed.
Okay, we really established the depth of the problem here. We've got bureaucratic inertia, we have technological lag, logistical fragility, all driven by these proprietary specs. Now let's pivot to the solution. The core argument in the material is that industry has already solved the interoperability problem, not through some government coercion, but because interoperability ensures profit, it ensures market share, and it ensures scalability. This seems to be the bedrock of the entire reform proposal.
It is. It's a recognition that commercial self-interest, the motivation of maximizing profit and market reach, is a stronger, a faster, and an infinitely more efficient engine for creating and maintaining standards than any government bureaucracy could ever hope to be. The solution lies in embracing what the sources call the Commercial Triad of Interoperability.
Okay, walk us through that triad again. What are the three parts?
It's threefold. First, actively leveraging existing industry standards, things like ISO and IEEE, instead of always inventing new military ones. Second, encouraging patent cooperation through things like consortia and licensing agreements, which we'll get into as the Xerox effect. And third, and this is the big one, implementing genuine capability-based requirements, focusing on what the system has to do, not rigidly prescribing how it must be built.
Okay, let's start with the primary analogy they use to illustrate this success in practice. It's the smartphone metaphor. The authors specifically use a device like, an iPhone or a modern high-end smartphone as the ultimate example of a successful global ecosystem that's built entirely on international standards.
It really is the perfect visualization of a global capitalist meritocracy at work. And it's critical that military leaders understand this ecosystem. I mean, just think about the component parts of a modern smartphone. That device is not the product of one nation, not even close. It's a compilation of intellectual property, of IP and hardware components that are sourced from all over the world. The design might be centralized in, say, California, but the display likely comes from South Korea, the application processor from Taiwan, the memory chips from multiple sources, and the final assembly from various other nations.
And what is it that forces all these diverse, competing, often geopolitically sensitive companies to work together so seamlessly?
Standardized ecosystems, that's the secret sauce. The device's functionality is predicated on leveraging global standards for every single operation it performs. 5G connectivity, Wi-Fi 7, Bluetooth protocols, USB-C for power and data transfer.
They're all universal standards.
They are. The supply chain operates as a meritocracy because every single component must adhere to a global, universally accepted performance standard to win the contract. So if a South Korean display manufacturer wants to sell components to a U.S. assembler, it has to meet the exact same ISO IEEE display standard that a Japanese manufacturer has to meet.
Now, I think the paper addresses a key underlying fear here. It's this idea that global integration automatically leads to security vulnerabilities or, a loss of some proprietary technological edge. Isn't there a common concern that if the military relies on global standards, its adversaries can just copy them or exploit them?
That's a legitimate concern, but the sources argue it really misunderstands the nature of modern global capitalism. This isn't communism, as the paper wryly notes. This is a robust capitalist ecosystem where IP rights are fiercely protected. It's a system where companies compete on features and quality, yet foundational technologies are shared for mutual gain through licensing. Standardization in this context is a strategic asset, because by using global standards, the military gains access to the deepest, the most resilient, and the most rapidly innovating supply chain in the world. A closed-loop military ecosystem, by contrast, is just inherently fragile.
And that commercial cooperation also happens through the pooling of IP, which the sources refer to as the Xerox effect.
The Xerox effect is such a powerful historical lesson in how competition and cooperation can and must coexist. Interoperability in complex industries, especially hardware and software platforms, is historically driven by companies pooling their intellectual property through consortia.
So how did that work for Xerox specifically?
Well, in the early days of the photocopier industry, Xerox held these proprietary patents that effectively prevented any competitors from entering the market, or even from creating accessories that worked with Xerox machines. But eventually they realized that by entering into cross-licensing agreements and patent pools with their competitors, by sharing certain foundational IP, the entire market expanded immensely for everyone.
They made the pie bigger.
They made the pie bigger. While they licensed the basic technology that allowed machines to function and use standard paper sizes, they continued to compete fiercely on things like speed, resolution, and durability.
So the key is this. The consortium allows companies like, say, Hewlett-Packard or Fuji or Lexmark to build products that all work together. That ensures interoperability, like a standard toner cartridge interface, while they're still competing like crazy on advanced features and pricing. That ensures profitability.
Precisely. Standardization creates the foundation for profit and for growth. The military's shift has to be this internal adoption. They have to start acting like a sophisticated customer of these highly successful, existing, self-regulating ecosystems. They have to stop trying to dictate the creation of new, bespoke, and ultimately inferior ecosystems that only serve one single contractor. If you need a robust network router, you don't go design a new military one from scratch. You demand a commercial-grade router that meets standard secure protocols and is available from 10 competing vendors across the globe. So to actually operationalize this shift, the military has to transition away from these unique solutions and fully embrace what we might call the universal operating system of global commerce. And this is where international standards organizations, specifically ISO and IEEE, become absolutely paramount.
We hear ISO and IEEE mentioned all the time in commercial life, but for the listener who might not know, can you just briefly clarify what they standardize and, crucially, what makes their process so superior to the government standards negotiation we talked about earlier?
Certainly. So ISO, the International Organization for Standardization, is famous for setting specifications for, well, almost everything. From quality management, like ISO 9001, to the physical dimensions and characteristics of components. And then IE, the Institute of Electrical and Electronics Engineers, they focus very heavily on technical standards for electrical engineering and computing. They essentially define how networks, like your home Wi-Fi, and data transfer protocols operate.
And their superiority lies in the fact that it's all consensus-driven.
Yes. They function entirely through consensus, not coercion. And crucially, their standards are developed in response to market needs that are recognized by industry players who stand to gain profit from wider adoption. So you have experts, actual working engineers, scientists, technicians from across the globe, negotiating these specifications for safety, reliability, and interoperability. A government mandate isn't what compels an engineer in Japan to share technical details. It's the profit motive of accessing the North American and European markets that does.
And that process, where the global market itself dictates the standard, creates what the paper calls a supply chain of standards.
It guarantees it. It ensures that a highly specialized ceramic component that was engineered in Munich can seamlessly fit and function within a major vehicle assembly line that's running in Texas. This market-driven, expert-negotiated process is just inherently faster, it's more flexible, and it's more technologically sound than specifications that are hashed out over months or years in some bureaucratic political conference room where technical expertise is often outvoted by national interests or lobbying power.
Okay, so let's apply this idea of standardization not just to digital systems, but to a profoundly mechanical and traditional field like ballistics. The sources highlight this under the title Standardization of Effect. The argument is that even here, in something as old as gunpowder, the military often overcomplicates the specifications.
They absolutely do. And this is where the distinction between input and output is so vital. The military traditionally dictates the precise input, the proprietary government recipe for the propellant. They specify the exact chemical composition, the density of every single grain of gunpowder, the method of packing. It's incredibly rigid.
And how does the commercial arms industry approach this differently?
The commercial arms industry, which produces massive quantities of high-performance ammunition for global consumers and governments, they standardize the propelling charge by focusing on the resultant effect, the output. The critical factor for round-to-round accuracy, for safety, for penetration power, is the consistent chemical energy that's delivered and the resulting pressure curves that are created when the round is fired.
So they don't really care how the gunpowder is made, as long as it delivers that guaranteed pressure curve within very specific tolerances.
Exactly. Commercial manufacturers achieve highly effective, reliable, and crucially, much cheaper ammunition by standardizing the chemical energy and the pressure curves, the effect delivered down the barrel, rather than rigidly dictating the specific, proprietary manufacturing method of every single grain. This focus on standardizing the effect allows for innovation in manufacturing processes, innovation in sources of raw materials, and it ensures consistency at scale. And that is the key to wartime logistics.
And the strategic takeaway from that is that this shift, focusing on guaranteed performance rather than a proprietary recipe, allows the Department of Defense to leverage massive commercial scale for accurate, penetrative ammunition. Ammunition that's available in massive, sustained quantities. In a high-intensity conflict scenario, the ability to rapidly produce accurate ammo is one of the most significant strategic force multipliers you could possibly have.
It is the very definition of sustained lethality. We have to stop obsessing over the proprietary recipe and start obsessing over the guaranteed performance envelope. If 5 different companies using 5 different internal manufacturing processes can all reliably hit the same standard pressure curve, we should be buying from all 5. That is industrial resilience.
This brings us right back to the core operational visualization here, the most critical pivot of this entire discussion, capability over specification. How do we actually make the acquisition community change their approach from being designers to becoming smart consumers?
It requires a total culture change, a complete rewiring of the system. They have to stop writing specifications and start defining problems. The contrast between the old way and the new ask is it's stark.
Okay, give us the hypothetical old way for, say, a communications device, a radio.
The old way is the 12-page specification. It details exactly how a new radio must be built. It requires a specific proprietary chip model from a named vendor. It mandates a specific custom-machined aluminum alloy for the casing. It demands a unique mil-STD for the operating system, and it specifies the thermal tolerances based on some decade-old test protocol.
And that instantly locks the contract into the hands of one vendor, the one who owns that unique recipe.
And the inevitable result of that vendor then has zero incentive to innovate. Why would they? They are guaranteed the contract for the entire life cycle of that specific technology, even if it becomes obsolete in 2 years. They simply maintain the contract structure.
Okay, now contrast that with the new ask,
Yeah.
the capability-based requirement.
The new ask is profoundly simple. The Department of Defense should issue a requirement for the capability to securely transmit voice and data encrypted to X standard, reliably over existing global commercial waveforms 5G, satellite, Wi-Fi 7, while maintaining connectivity under Y environmental stress factors.
And that capability requirement, it breaks the monopoly lock immediately. because the DoD is no longer dictating the solution.
Exactly. Industry solves the how. They solve it using the cheapest, most effective path that's already been established by the global commercial market. So any vendor, whether they use chip A or chip B, whether they use standard commercial software that's running a secure military layer, whether they house it in carbon fiber or a standard alloy, any of them can compete as long as they meet the established, measurable, secure commercial standard for that capability. And that immediately injects competition. It speeds up innovation by leveraging global R&D, and it radically increases your supply base resilience because you now have dozens of qualified global vendors instead of one single proprietary source.
So this whole concept of adopting global standards, it goes far beyond just efficient procurement. It touches directly on geopolitical power and industrial resilience in a high-stakes conflict. And there's this common and I think understandable fear, especially among allied nations, that standardization is just code for buy American or outsource our critical defense functions.
That is a fundamental misconception, and the sources address it head-on. They argue that adhering to international commercial standards actually preserves national sovereignty in manufacturing. It doesn't surrender it. This is the key difference between a global standard and a national standard.
Okay, help us delineate that distinction.
The standard itself, let's say an ISO standard for a specific optical component or a data interface, is global. It's universal. It's non-proprietary. Therefore, a factory in France, a plant in Germany, a specialized facility in Ohio, or a manufacturer in South Korea can all manufacture those subcomponents to the exact same global industry standard.
Which means the U.S. can demand equipment built to that global standard, and its allies can supply it while simultaneously supporting their own domestic industrial bases. This sounds like resilience through distributed manufacturing.
That's precisely what it is. It creates resilience through industrial diversity. And the sources acknowledge this. Relying on a truly distributed, sovereign manufacturing base might introduce slight cost increases compared to, relying on a single monopoly that's focusing only on the lowest wage location. But the strategic trade-off is invaluable. It creates a robust, geographically distributed industrial base across the entire alliance.
And the scaling advantage of that diversity would become decisive in a peer conflict, I would imagine.
It is the ultimate strategic advantage. In a high-intensity global conflict, if one manufacturing node, say, a specialized factory in Poland or Ohio, is destroyed or disabled by adversary action, other nodes across the alliance can scale up immediately.
Because they're already on the same page.
They're already tooled to the identical global standard. This process transforms the diverse, commercially driven supply chains of the free world into a decisive, self-healing industrial advantage. And that contrasts sharply with the brittle, centralized production models that are typically favored by authoritarian adversaries who rely heavily on single, concentrated supply points.
So the arsenal of democracy, redefined for the digital age, becomes a network that's built on interoperability.
Absolutely. The standards ensure that even if the U.S. is primarily buying a standardized product from an American company, if that company suddenly goes offline for some reason, French or German companies already tooled to the same global commercial standard can step in instantly to fill the gap. It is collective industrial security.
Now, this kind of shift requires a radical change, not just in the procurement processes themselves, but in the leadership pipeline. The military leaders of tomorrow, they need a different skill set than the ones who were managing contracts back in the 1990s.
They need to become what the paper calls educated consumers. Future leaders, from a platoon leader who's coordinating digital assets on the battlefield, all the way up to a program executive officer managing a billion-dollar portfolio. They don't necessarily need to be able to write code or design processors, but they must understand the metaphors of the technology.
What do you mean by that, understanding the metaphors of technology?
They need to recognize that the simple, everyday act of, say, plugging in your phone or setting up a home Wi-Fi network relies on this complex, highly efficient, and globally negotiated web of existing standards. USB-C, Thunderbolt, various Wi-Fi protocols. These leaders have to recognize that the military should readily adopt and leverage this global architecture, rather than trying to waste time and money replacing it with a unique MIL STD that will be slower and less secure by definition.
So the culture shift really moves away from leaders who only excel at managing contracts and calculating risk on an Excel spreadsheet. And it moves towards leaders who possess a deep strategic understanding of supply chain dynamics and global industrial capacity.
That is the ultimate goal. They have to understand that adopting commercial standards is not a surrender of control or sovereignty. It is a strategic move that increases industrial resilience and operational speed. The new metric for success isn't just ensuring a contract stays within budget, it's maximizing competition and leveraging the global capitalist ecosystem to our advantage. Leaders have to understand that global standardization is the most profound force multiplier available to modern military power. So, what we've really analyzed today is a fundamental paradigm shift. By proactively adopting this commercial triad industry standards, patent cooperation, and capability based requirements, the entire Western Alliance can create a self reinforcing, highly competent an ecosystem that runs at the speed of the global market, not at the speed of bureaucracy.
Okay, so let's synthesize the core strategic benefits that the sources promise from this kind of transformation. What are the big takeaways?
Okay, first and foremost, innovation is rapid. We stop relying on the slow, expensive, and frankly small R&D pool of the defense industrial base, and we start leveraging the entire free world's technological advancement. Second, monopolies are broken. We replace these fragile, single-source dependencies with a robust, competitive marketplace of qualified vendors. And that also removes the perverse, revolving door incentive structure that promotes stagnation.
Third, and this is strategically vital for alliances, sovereignty is preserved. Allies can build their own domestic protected industries that all feed into a globally compatible, standardized system. And fourth, resilience is secured through these diverse, geographically distributed supply chains that are capable of rapid scaling and self-healing during a high-intensity conflict.
And finally, and this is the bottom line, lethality is scalable. We move beyond these boutique, high cost, low volume solutions, and we start equipping a new generation of leaders who are capable of orchestrating warfare using the best, most rapidly producible tools the world has to offer. And those tools are backed by the full industrial might of a standardized global network. The goal is millions of reliable rounds, not thousands of proprietary ones.
So what does this all mean for you, the learner? It means that when you read about military procurement or international alliances, you need to look past the flashy piece of technology itself. Look past the new jet or the new drone. You need to understand that the most powerful, the most decisive weapon an alliance can possess today is not a new piece of hardware. It's an efficient, resilient supply chain that is built on global commercial standards. That supply chain is what determines your speed, your quantity, and your sustainability. And those are the true arbiters of victory in any protracted conflict.
And this raises a really important question for critical thought. If industry collaboration is already driven by profit and it demonstrably results in superior, cheaper, and more scalable products, is the government's role in technology acquisition truly to design anything anymore? Or is it merely to define the performance demand and then rigorously enforce the use of already successful global standards? And furthermore, if the military is being hampered by this mechanical mindset applied to digital problems, how many other industries that are vital to national security, from food logistics to energy grid components, are currently hindered by the exact same bureaucratic flaw? Something to mull over as you observe how the global economy really intertwines with national security.